Hello, everybody. My name is Tavi, and I'm the CEO and co-founder of Dashbird. Today, we will be co-hosting a webinar with Tim from AWS, and we will be talking about the well-architected framework, building complex serverless architectures, and maintaining them, building them as well as possible, and how you as a developer or an engineer should think about topics around security, reliability, monitoring, and iterating. You can ask questions during the presentations, and we will address them later once we've done the demos and the presentation. So I hope you'll all enjoy it. This will also be recorded and shared later. So if you, yeah. So I'm happy to introduce Tim from AWS. Tim, if you want to talk a bit about yourself, and then get started.
Sure, and hello to everyone out there. It's really nice to be here. I'm calling all the way from Singapore today, so this really is an international audience for me. So it's really nice to come and chat to you all. My name is Tim Robinson. I work for AWS. I'm what we call a well-architected geo solutions architect. I've been responsible for the last 2 years for building out well-architected across Asia. We've pushed very hard from a well-architected perspective in the last couple of years, and especially in Asia, I've spent that time dedicated to driving best practice within our partners and also with our customers. So it's great to be here today. We're going to run through a brief overview of well-architected, perhaps start with a little bit of the history about how well-architected as a movement has evolved, and then we'll go into the value of the well-architected framework, a little bit deep dive about how it's structured. Maybe we'll talk a bit about lenses, and then we're going to pass across to Tavi, who's going to talk about how he can help specifically in line with best practice on serverless architectures. So let's get going. We have the first slide.
Awesome.
Okay, so if we build this slide out, we can kind of see that well-architected started in 2012. It was started initially as a response to the fact that AWS was really building out its portfolio of services. These services all had documentation associated with them, and there was a lot of feedback from customers and especially from the media at the time that a lot of the services were quite complex in structure, and there really wasn't a great deal of guidance in terms of best practice. So this was why well-architected was formed as a group in 2012 with the expressed intention of working to disseminate best practice and having really a single focal point within AWS to drive adoption of best practice and ensure that that education is passed out to our customers. So in 2013, we started to actively run architecture reviews. So these really worked across our SA community, going out and talking to customers face to face. And over the course of a sort of a 3 to 4 hour review cycle, they were able to understand what the customer had deployed in their environment and really give them a gauge on areas that they thought they could focus on, perhaps over the next 6 months, really areas they could refine and develop, and really how we could help them to improve their architectural posture. So by 2014, we'd separated into individual pillars, and we aligned questions with each of those pillars. And in 2015, we published the first framework document. So if you search now for AWS well architected, probably one of the most searched for documents is the framework or the white paper, and that was published in 2015. So by 2016, we realized there was a massive onus on operational excellence, and we'd really worked from a purely technical perspective, really focused on the offerings that we had to date. But we also got a lot of feedback from our customers that what they were concerned about was, in addition to the service portfolio that they had within their estates, is really working to understand how they can improve their operational posture, how they can reduce a lot of heavy lifting, and really how they can improve day-to-day running. So the operational excellence pillar encompassed that. We released that in 2016. By 2017, and this was really when I started to work with AWS as a partner solution architect. But by 2017, we really started to get a massive proliferation of services, and these spanned across, I suppose you would call it, your more classical architecture of perhaps EC2 instances and relational databases, all the way through to next generation architectures such as containers, and then into Lambda and serverless. So we really wanted to be able to cater for that segregation of environments, and really we appreciate that running a review against classical architecture is perhaps very different to running one against a serverless architecture. So we started to work towards building out lenses. And these lenses would overlay the framework itself and allow a reviewer to really talk in depth with regard to a specific workload, be it serverless, IoT, or anything of a very refined nature. So by 2018, we started to build self-service improvement plans, and into 2019, where we built out regional launches. So I'm sure most of you know, but we have a well-architected tool within the console, and really working to refine that tool so that we could offer that out to customers for them to run their own reviews themselves, but more importantly for perhaps architects or partners to go in, run reviews in alignment with the customer and produce improvement plans. And again, into 2020, we've produced a number of framework updates. We've actually done a complete update across the framework, all of the pillars. We have a release of the serverless lens that's now in the well-architected tool, so you can now go and take a look at the tool actually in the console itself, and really working to align those reviews with owners. So let's move on and talk about why we would really use well-architected framework from a value perspective. So really, if we build this slide out, perhaps the first point is that customers really want to build and deploy faster within their environments. What we see traditionally is customers start in this period of experimentation, and they're able to build quite quickly with our services. And gradually over time, their workloads tend to develop almost organically, and they add to them over a period of time. What we find is that as that time length increases, if they've deviated from best practice or they're not really aware of best practice, it gets harder and harder to layer that complexity on the top of what they've already delivered. So really teaching people to align what they've got with best practice ensures that they can build and deploy a lot faster, and also in a lot more secure and a higher security posture. If we look at lower or mitigating risks, again, I just touched on security, and when I talk about risk, people normally associate it with security, but really this spans pillars, and this goes into both reliability and performance, and to a certain degree cost as well. Our review process and our alignment with best practice works to lower or mitigate all of those risks over a period of time. More importantly, and I'll talk more of this in the next point, but a lot of customers aren't really aware about where they sit in terms of a risk profile. And for sort of C-level audience out there, this is really something that keeps a lot of C-levels awake at night. Is number one, where do they sit in a risk profile, perhaps from, well, let's use security, for example. But more importantly, how do they go about reducing that risk in a structured manner, perhaps over a 6 or a 12-month time period? If we look at making informed decisions, this is very important. Once we create a risk alignment, we then have an idea about the work that would be involved to maybe remediate an architecture, and then we can move to make informed decisions. So an example of this would be something like a customer has had a workload in their environment for maybe a 2 to 3 year period of time, and now they're looking to redeploy that workload into a fresh environment, perhaps an environment with segregated accounts or something similar. Really, there's a decision that needs to be made. Do they really work to improve and to remediate their existing environment, or do they just migrate into that fresh environment? And really running a well-architected review will give you visibility of the work that's needed in order to make those remediations, and ultimately it gives you an ability to make those informed decisions. Finally, and probably the most important, is the ability to learn AWS best practice. And that works for the customer, and it also works very well for AWS. So from my perspective, it's always been true that happy customers are normally well-educated customers from a service and platform point of view. So the more we can instill best practice ideology and knowledge about new releases, release cycle, how services evolve over a period of time, normally the happier customers are, and the more they're willing to share and build that trust with us. So let's take a bit of a deeper look into the well-architected framework and see how it's structured. So from the left and going right, we have pillars, we have design principles, and we have questions. So our pillars are really what we see as the cornerstone of architecture, and really the vertical segregation that we would apply to really any workload out there, regardless of whether it's serverless, perhaps an EC2 environment, big data, whichever it is, we still have the same pillar alignment. And I'll talk about the pillars in the next slide. We move on to design principles. So what really do design principles represent? These ultimately represent the goals that we should achieve within each pillar. So think of these as really the objectives that we feel that a workload should be achieving within each of these pillars. So when we run a review with a customer, how do we understand if these design principles are being met? Well, the answer is really we ask questions. We look at architecture diagrams, we gather information before the review, and a combination of all of those together helps us to go in and really run a data-driven, informative review with our customers. So let's move on and talk about the individual pillars of well-architected. So I touched on these at the start of the presentation, but operational excellence is our first pillar. So really the ability to look to understand how customers operate their workload. If they're perhaps spending a lot of employee time on daily routine tasks, maybe something we could automate. Are they really achieving their business objectives, or are they being caught in amongst daily the daily grind of maintaining that posture? All of this really goes into the operational excellence pillar. So next we come on to security. Again, when people think about security, classically this would be perimeter security, but we really think of security as security at depth and at every layer. We have security aligned with all of our services inside AWS, and we really see this as a day one initiative. So security is very much one of the early pillars that we cover off. So next is reliability. Again, the ability to withstand perhaps a geo-specific event, or an event even within your environment where you'll need your application to remain available. So what measures has that customer taken in terms of ensuring that their environment is fully reliable regardless of the event that's going to take place in the future? So we look at performance. Performance classically used to be very much a speeds and feeds style conversation, but really now it bleeds into sort of scalability. So if you're running a website and it's a Black Friday or something of that nature, you're probably going to generate a lot more traffic. So is your environment able to scale out? Is it elastic in its nature? Is it really able to cope with that that increase of traffic, maybe 5, 6, 7-fold on what you get on a daily basis? But really working to ensure that performance efficiency is there. And again, that works in reverse as well. So ensuring that you're not over deploying perhaps services that are too compute heavy, and again that's having a impact elsewhere. And finally, cost, always a popular pillar. I think going in to run reviews where we can talk to customers about cost optimization always comes with a welcome smile when we talk to customers. Again, cost optimization is really something that we really find quite positive with customers. So as we evolve services, perhaps from a compute perspective, we find that maybe we can talk to customers about using new instances that are perhaps more efficient. Maybe we can talk to them about different cost modeling, maybe moving to spot instances for certain areas of their architecture, or indeed working with perhaps a partner or a technologist independently to help them to maybe recode some of their application, maybe aim towards microservices or towards Lambda. Again, all of these things have a cost optimization target. But yeah, there we go. So there's our 5 pillars of well architected. We use each one of those pillars really in a review context. So we can talk through the intent of a review now. So again, working left to right, when we run a review with customers, it's really intended just to provide insight into best practice for AWS. It's not intended as an audit. We have customers sometimes concerned that it's aligned with an audit, or somebody's going to turn up the clipboard or something of that nature. We're not aligned to any regulatory body. We're not aligned to auditors. We don't feed data back to any third party, anything like that. We're really working with the customer to improve their posture and to suggest areas where they should focus in the future. The second point I'm very passionate about is that we're not really architecture astronauts. So what does this really mean is that we really provide pragmatic, proven advice that we know works, and we really work to tailor that advice according to the customer's need. Again, if the customer's got a real requirement to have a very tight security posture, we would bias the review in that direction. And again, if the customer's concerned about increasing cost, we can definitely take that into account and run a review with a very deep cost edge to it. So more importantly, these aren't really intended as a one-time check. Really, we want to run these reviews or run these best practice sessions with regular cadence, and they really should be run throughout the life cycle of a workload. Again, running these in regular cadence, perhaps twice a year, ensures that there's no, even from a security perspective, there's no glaring holes in your security posture. But really working to ensure that any large issues get caught early, and that we maintain cadence with the customer, and we're able to offer that efficiency in a regular cycle. So let's talk about lenses. I mentioned them briefly at the start of the session, but we devised lenses to really be specific to a workload type. So we found that running the same review across such a diverse array of workload types did have a positive effect. But what we really wanted to do was to be specific in terms of workload. So we've gradually worked to build out individual lenses within the well-architected framework. And what you'll see in the next year, and again towards the end of this year, is gradual integration into the well-architected tool itself. So if we look at these individual lenses, the design principles are really there to be specific to the lens. And if you look at the lens documentation there, it's really aligned to include popular scenarios. If you look at the serverless lens, for example, you'll find RESTful API scenarios, mobile device scenarios, etc. So these really are best practice documentation. But in addition to that, documentation on how you should really work to combine our services with the maximum effect to really achieve the business outcome that you're looking towards. So scenarios, as I say, do include the reference architecture, and the lenses are available across quite a wide variety of workload types. We have the serverless lens in the tool. We also have lenses available for high performance compute, analytics, IoT, and again, more being released all the time. As I mentioned earlier, these will gradually be integrated into the console, into the well-architected tool. So watch for those coming along. So I know Tav is very aligned to serverless. So I kind of wanted to go into some of the serverless design principles. I don't want to steal his thunder, so I'm going to go through these very quickly, and then I'll hand back to him. So if we just go to the final slide.
This one?
We might have got a slide missing, actually. Let's just go to the previous one.
Sure.
Yeah, that's great. Awesome. Okay, so we've got 7 design principles here. Again, very, very different from the traditional design principles, but we would kind of expect that with the fact that we're dealing with quite a specialist workload. So what do these design principles really mean, and how do these fit into serverless design and really work to form our base design principles for the lens? So I think the first one's quite interesting: speedy, simple, and singular. So really working to make sure that functions are concise and they're single purpose in nature. A lot of customers are really moving away from monolith design. And what we find when we educate is that when we look at some of the Lambda code that's produced, it's run in almost an identical manner. So we're not looking to build out huge lambdas that are like a Swiss Army knife. We really want these functions to work independently and to really be specific in their nature. So moving on to concurrency, really serverless applications, one of the main advantages for me is that they make full use of the concurrency model. So this means that really trade-off at the design level is really evaluated based on concurrency. So we don't really need to be bound by total request. We can really take advantage of that concurrency model. Share nothing really points at the fact that functions are quite short-lived in their nature, and therefore underlying infrastructure isn't really guaranteed. So really persistent storage in a decoupled nature is kind of the preferred method for durable requirements for storage, and really saving stuff in that decoupled method. So assuming no hardware infinity is probably quite key. So what does this really mean? Well, if we look back in time, perhaps using things like CPU flags within your code or something like that would be common practice. Really today we're looking at underlying hardware changing without your knowledge, and really looking to use the technology in a hardware agnostic method. So really assuming that there's no hardware infinity and working to code in that direction means that your code will work across a breadth of time, regardless of the underlying hardware architecture. So orchestration is probably one of the key benefits to serverless, and again, chaining functions together is really akin to our standard monolith design. So please don't do that. We've got state machine structures there to build out that complex orchestration for you. So try to make full use of those, and again, combining that with the fact that your functions work in a precise and singular manner means that you can build out those complex workflows. Using events to trigger transactions. The people familiar with serverless, this is kind of a given, but it's really event-driven architecture at its core. So events such as a write to S3 or a database update really allow for a response which is in alignment with business functionality. And again, this is what we'd expect is for anyone designing an architecture to use that event-driven methodology. And finally, really a nod to our reliability pillar, but really designed for failures and duplicates. So this shouldn't be really news to anyone, but failures can occur, and an event or a request can really be delivered more than once in some circumstances. So really work to ensure that you include appropriate retries for downstream calls within your code. So that's kind of very high level about well architected, and perhaps a little bit of an overview on what we're seeking to achieve specifically from a serverless design principle. I'm going to pass across to Tavi. He's going to take you through Dashbird and really how the technology that they're focused on helps in that serverless design and really works into these principles that we've talked about. So Tavi, over to you.
Awesome. Thank you so much, Tim. And this was really informative in my opinion.
Thank you.
So I'm happy to go into kind of the journey of our philosophy around a lot of this and kind of how we approach companies and people building serverless applications. Just want to recap here what Tim said earlier. So kind of what are most of our customers helping or like trying to achieve when they come to us. They're looking to build and iterate faster. That's, I think, the key also for going serverless as well, that it enables you to go much faster. For a tool like Dashbird, they're hoping to mitigate risks and gain confidence in their processes. So to be able to quickly make changes to the infrastructure, to build new features. They want to make informed decisions and they want to follow best practices. So those are really kind of the fundamental ideas that we see our customers striving towards. And also kind of to go over the challenges that we see people facing today. So I think one of the main kind of fundamental challenges that we are seeing in the market and kind of when you're building something at scale with serverless is that you end up with a lot of surface area and a lot of different services, a lot of functions, a lot of managed services, and they all work together. And sometimes that might be a complex environment to understand what's going on, to effectively navigate information. And that brings us to the next point, is that actually in some cases and at scale, a significant amount of development time can actually be spent on debugging. And this is also something that you are kind of sometimes struggling with. When I was at my last company before starting Dashbird, our kind of main concern was actually responding to incidents quickly. So, even though it's serverless, developers make mistakes and things happen, and you need to be able to quickly respond to incidents, and you need that confidence that whenever something fails, you're not going to be hearing it from your users, but you're actually going to know pretty much as soon as possible in real time. And also kind of the last concern that we had, and also a lot of our users have, is that there's so many services that you're all of a sudden using. There's a lot of complexity. How can I ensure that I'm actually following the best practices? People want somebody to tell them, or kind of somebody to continuously check and kind of recommend how to be better, basically. So kind of that's how with what customers come to us, and if it's something that you are struggling with or are thinking about, then hopefully the next bit will basically make sense to you. So just kind of throwing it out there, how can tooling help with those challenges? So I think the first and one of the most talked about areas is observability. So as I mentioned, the biggest challenge is basically this really large surface area with tons of different monitoring data going around. So I think that the data should be centralized and it should be accessible to the developers as well as possible. So here we should consider things like looking at between different data types. So logs, metrics, and traces not being in silos, looking across the spectrum of managed services. So not just compute, but how does your SQS queues interact with your Lambda functions? How is your API gateway performing? How are the step functions doing? Do you have any problems there? So really not just one or two services, but you're dealing with this whole spectrum of different managed services. I think the other really obvious thing, and I would even say the biggest pain we've seen, is reducing the time to discovery and resolution. So really, the tooling should help you cut the time it takes to know that something is wrong, and also once you know that something is wrong, to basically tell you what is wrong and how to fix it as well. So another kind of product idea, or also kind of a thing that could be solved automatically, is enforcing or recommending best practices and scanning the infrastructure for configuration inefficiencies and any sort of problems along the way. Really, I think tooling should be like for serverless, and like if we talk about things like monitoring, security, alert, and kind of failure detection, a lot of the things come down to automation and abstraction. So if you think about, you're perhaps using Cognito somewhere, or you're using SQS queues, for a team to, first start using SQS queues, not only do they need to implement them, but once they kind of, do that, they need to understand what are the risks associated with that and how do I monitor that. And then once you start adding new queues, for example, or new functions, that kind of alert coverage and the kind of monitoring for the unknown failures must always be extended to the architecture. So I think in this case, your tooling should adjust itself to the ever-changing infrastructure and should know before you what you should be monitoring for. In my opinion, also what a lot of our users struggled before was actually building it yourself, and then you have to manage a lot of the underlying infrastructure. So for example, if you're ingesting logs to a log pipeline, then you would need to manage that. If you're building your own alarm systems, then that's also a thing to manage. So I think that the kind of taking away the management of the underlying infrastructure is really the serverless way, and it's kind of a big boost for teams. And I think the last thing is basically to enable learning by making it really understandable and really clear what the system has done historically, how has it performed, and how have changes affected the system's ability to perform over time. So this is how we think about it. And to come into Dashbird a bit more, so the way we approach this is threefold, and our product and platform theory and kind of the way it's built is based on three core pillars. So the first thing we do is we connect your AWS account, and then we ingest data across all of the managed services that you might be using. And we do that across silos as well. So we ingest logs, metrics, and tracing data and configuration data. And so what that gives you is a platform where whenever something happens in your environment, there's one place you need to go to that has all the answers, and you can dive from an account level overview into detailed execution or transaction view. So that's kind of it takes away the need for multiple tools to go around and search for data. And we see this as one of the biggest kind of increases to the effectiveness of development teams and really enables companies to build faster. The second pillar of Dashbird is the automatic detection of any kind of a problem that you might be having. So what that means is if you have something in your logs that would indicate a failure of some sort, or if you have a metric data point across any of your managed services that is indicating that you have a higher delay or a failure somewhere, then that would be surfaced and notified automatically. So you don't need to manage that, but you also don't need to develop the domain experience around different services and kind of know how to monitor them. We tell you what you should be focused on. The last pillar, and actually probably the most relevant to this talk, but also into my mind the most exciting and the recent, is running insights checks that look at like how well architected your system is. So this actually came quite recently, and kind of how we ended up here was that we were looking at all of the different data points we have for a system and thinking like, hey, we can actually do a lot more abstraction and automation on top of the data that we currently have. And so we started doing checks and kind of recommendations on how to improve your serverless infrastructure. So let's go into a bit deeper into all of those value propositions and kind of the pillars of the platform. So with decentralization, we aim there to be one managed, automatically scalable and central place for all of the data that you have for your infrastructure and all of the data that you need for your infrastructure. And to have that data available as kind of conveniently as possible. So you can, so essentially it's designed to give back development time and also to increase the confidence and understanding of the system. So you can do things like query, you can search logs, you can visualize logs, metrics, and traces. You can go into a transaction level, like one Lambda invocation, and see what services it was communicating with, what was the goal start, the memory usage of that, and like a lot of different things. You can also catch retries. You can see how retries are linked in time and if they have eventually succeeded or not. And this is not just for functions, but as I mentioned, we're supporting a wider range of AWS services that are used together with serverless or are considered serverless. Another thing, as soon as you onboard to Dashbird, is we start discovering your resources and ingesting data for your resources. And for example, you have 1,000 Lambda functions or 100 functions, it doesn't matter. As soon as you connect Dashbird, we would tell you all of the code exceptions, all of the timeouts, all of the configuration issues across all of those functions, and would act as an incident management platform. So you can look at the individual invocations, you can see what was the underlying event that caused this, and you can see all of the kind of occurrences of that failure. Same goes with metrics as well. So we have a broad variety of different checks. So for example, if you have a high delay in your SQS queue or you're consuming items at the lower pace than you're actually putting them into the queue, all those sorts of inefficiencies would be caught and you would find them in pretty much real time. Think about API gateways, even ECS clusters, Kinesis throttling. So really we kind of know what to monitor for, and we abstract away kind of the pain of managing alarms. And the last part is currently we're featuring over 60 community curated, well-architected checks. And really the check can be across a different, like a variety of different types. So we can check at metrics. For example, are you in risk of running into a memory outage? Are you perhaps over provisioned so you have the ability to save a bit of money? Should you be encrypting your databases? Should you have detailed monitoring enabled or logging enabled? So there's a lot of different things that across the pillars, actually across security, cost optimization, performance efficiency, and operational excellence that we provide to you. So you end up with this actionable list of items. So for our customers and the users, really what they get is increased reliability and iteration speed. They go a lot faster if they have Dashbird telling them if something is wrong, but also if Dashbird gives them the ability to quickly understand the ins and outs of the system. It helps during the development workflow as well. Really kind of the core idea of serverless and the value proposition of serverless is you can focus on the customer and you don't need to do the undifferentiated heavy lifting. And that's really also what we feel like we provide is we give the focus back to basically only think about the customer and not worry about, how am I debugging this? How am I managing alarms? How do I know that something is working or is not working? And over time, we direct customers to achieve the best practices of the industry, and this really has an effect on their ability to stay cost optimized, performance optimized, and manage the posture of their infrastructure over time. So thanks a lot for listening. If you have any questions, we're happy to take them, but I don't see any right now. I hope I'm looking at the right place. Awesome. So that's it from us. Thanks a lot, and join us again next time.
Thanks a lot, everyone. Have a great day.
Thank you.